Now, students, I'm going to bring you through a little bit of work that we did in studio yesterday so that you have a full understanding of this. This is an architectural group called Hawkins Brown, and they're all over the world, a very big firm, which allows them to spend money on research and development. And they're very interested in the embodied carbon material selection for their buildings and things like that. So what they've done is they have developed a particular application, which is an add-in into Revit, which will do some of that calculation for you. Now I'm going to kind of little skip through this process a little bit and show you how we can get in there. But one of their research areas is this one, environmental intelligence. Okay, and you can have a read of all of that down here. That one being embodied and whole life carbon analysis, and the tool that they've developed for that is called the HVERT version 2 or VERT. So this one is morphing into this one here. This will be the latest version, and you can click in there and have a little read. And if you go down to, you can find out more here. If you click that, you fill out some information and they'll send you an install package for this. Now I'm going to do a little workaround, as I said. What I've managed to do is to get hold of one of their Revit models. It's called the HVERT Revit 2022.rvt, and I'll put this up on the Engaged community for you. So I'm opening up this file, and I'll go into a 3D here, and it looks as if there's nothing there except a block, but there's lots of really good stuff in the background here. Okay, now I'm going into manage and I'm going over to materials. Now these are all the HVA underscore materials, and there is a very good selection of the materials here. Not everything is there, but there's a very good selection. Why are these different than the default material library that we have been using since first year? And I'm going to show you this. So if I go into, say, Screed or something like that, what it's got is all of these materials have either physical and thermal or physical assets attached to them, and these assets are validated assets. Okay, they come from EPDs, environmental product data sheets, or from the manufacturer or something like that. Okay, so they're closer to being correct than the default ones that you would take out of the asset manager and associate with your material within the Revit environment. All right, these are already set up for you. They have some identity data here as well, which is handy. The graphics are not great. You might need to go in and adjust the graphics to your preference. In terms of concrete, and the way we like to have our insulation colored a very light yellow, so we can see the wraparound of the insulation in the building and things like that. All right, they do have rendering appearances associated with them as well, but for me this is the interesting bit, is the assets that are associated with them. So we've got density here, we've got thermal expansion coefficient and things like that, other thermal conductivity and that type of stuff there. Okay, now if all that information is associated with the material, we're in a position to calculate the embodied carbon of the calculated volume of that material. That's where I'm getting to. Now, how do we get these materials into the project? Okay, so I'm going from the Hawkins Brown project into my own here. Okay, I'm going up to manage and I'm going into transfer project standards. I'm going to check none. Now make sure you're copying from the HVERT, okay? And you just go down and we'll check materials and we'll go okay. And then at last, do you want to overwrite and whatever else. Now I've done this already, so I would suggest you overwrite, okay? And it'll actually go and put those materials in. So now I'm in my TDS project here, and you can see I've got all those materials are there. Now, what do you do with those materials? So we're coming into my exterior wall here type, and I'm going into the type properties and into the structure here, and you can see that I have associated with the HP wood the laminated vertical cladding that I'm going to use, soft with counterbattens, vertical and horizontal. So in order to create those, I literally just duplicated with assets the material, one for the vertical, one for the horizontal. There's two different thicknesses of those. Here's the rock wool material. Okay, I'm going to use that for my insulation, and if I just pop in here and give you an example of that. Okay, so there's rock wool, there's PUR, there's mineral wool, expanded polystyrene. Okay, so you got a decent choice there. And in the physical properties of that, I've got a density here, which I'll use for my calculation. I've gone into the graphics, and in the cut pattern, you can see I've just changed that to the very light yellow, 255, 255, 230. That's what I like for my graphic version of the insulation. Okay, so what you will do then is you will go and as you are building your walls, your floors, your structure, all of that, what I want you to do is to use those HBA materials rather than the default ones. Now, how do we make use of that? So I'm back into Hawkins Brown here, okay, and if I come down to their project browser, you can see that they have schedules. They've got an embodied carbon and an embodied carbon library. I'll just take a quick look at the library first. So what we've got here is all the materials, the material volume, the density associated with those materials, and then there's there's a material weight, which is that calculation there. There's a waste factor, which is important to add in as well for the embodied carbon calculation. There's the overall weight. There's the factor that's associated with the embodied carbon factor that's associated with that material, and then there's an overall calculation here. All right. Now, if I go into this one is set up for us to work. All right. How do I get those, or specifically this one, into my project? And this is how we're going to do that. So I'm back into my basketball project here, and we're going to architecture, into insert, sorry, and then we use this tool here. This is insert from file. This is a really useful tool. So insert views from a file. So from any file, okay, I can do that, and maybe it's in documents, is it? Yeah, there's my HBERT. I select that one and I hit open. And what it's doing now is that it's showing all the views and sheets that can be transferred across from one project to another. And what you're going to do is you're going to check this one, the embodied carbon. You can check both if you like, and bring those. We don't need anything else from that. All right, and they will transfer across now into the project. Now I've done this already, so I'll show you down here into legends and into embodied carbon. Now, so it's already starting to pick up my concrete cast in situ, my blockwork, my plasterboard. It's calculating the volume of those for me, and then using all the factors here, which comes right across to the overall embodied carbon of ton of CO2, which is this here. And it's got a built-in formula which is doing that calculation for you based on those validated figures, and we're getting a total here. It has other things here like material transport and construction coefficients. They're more for LCA, for life cycle assessment. I'm not hugely concerned with those for this project. What I'm interested in doing is getting as close as possible to building up a total of tons of CO2 for the building based on the materials that we have selected. Now that's the hint, so that if things like concrete are coming up, the obvious ones come up the highest, you know, the concrete and stuff like that. So if we were able to substitute out say the 25, which is 25 Newton, 30 or 30 Newton, 25 aggregate concrete, in for one of those new concretes that they're producing that have a lower embodied carbon count, well, that drops the whole overall figure of embodied carbon, and I might be able to hit my targets, my RAI 2030 targets, or EU targets that are seem to be produced every year now, and this is a way to do it. Now, what will happen if there is a material that you want to use that is not in the Hawkins Brown material library set? Well, then what you need to do is go in, find out some information about that material, and this is one of the exercises that we did at the very start of the year, where I asked you to go in and investigate EPDs and so on, and manufacturers' data sheets and whatever, and you need to find out what would be the density of that material, what is the embodied carbon factor, also what else, enough information so that you can adjust. Okay, if I go back into my manage into my materials here, okay, and I just go down to say this is the one we've always used, concrete cast in place. You can see there's no physical or thermal assets by default associated with that. I can add them in. I can add physical assets in here, and I'll just do CONCRET. Okay, and there's the 2530 concrete, and if I add that asset in there, okay, it's now coming up. There's the physical asset, and here's the density. Now, what will happen is that it's very possible this might be right, but it's a default that they're using, if you know what I mean. So we need to go in and check that and make sure that that one is correct against that. It seems to have a Euro code associated with it, so it mightn't be far off. I think Autodesk are improving this as they go along. So what I'm showing you here is that you have the ability now to take maybe a default and actually go and adjust the kilograms per meter squared figure, expansion coefficient. If I wanted to add in the thermal assets, I would do the same again. And find concrete here, so solid concrete, add in those ones, and again it's just adding you know, things like thermal conductivity and the density here, 2.3. There it is again. Okay, all of those will be able to pick up and do that calculation for you in order to get your total. So it's very important that you understand this, and it's very important that you understand the necessity to use validated data when you're doing that calculation, because you don't want to be too high or too low. You want it you know, correct, basically, so that you can make this decision perhaps to swap out one material for another. So one of the couple of other reasons why you need that, I think it's quite possible very shortly that as part of a planning application, you need to do an embodied carbon report on the material selection as well, and that'll go along with the planning permission. Also, clients now, you know, particularly government clients, you know, public clients will be under pressure in terms of any new buildings that they'll be doing to make sure that they're hitting the targets, are coming below the targets, are doing better. And again, to do that correctly, you need the validated data. There are other applications out there, LCA applications and various embodied carbon calculators and things like that as well. But for us as architectural technologists, I think this is a really good way of doing it within the model. And so that's now giving you a good start in terms of the material tool set, but also showing you how that you can adjust defaults to get them correct as well. Okay.